All right, this is exam number 2 for Physics 101 and Fall 21. Let's look at the free response. So first, kicking a ball has certain mass. It turns out the mass doesn't really matter. I have this ball that goes up and then comes back down again. The angle here is 60 degrees. It has an initial speed, v naught, equal to 22 meters per second. And then I want to know several things. I want to know what is the maximum height of the ball. I want to know what is the maximum horizontal range of the ball. How long does it take for it to come back to ground level? And then what is the speed of the ball at a particular time t equal 3.0 seconds. Now, remember, I know that v in the y direction at the top is equal to 0 meters per second. Before we start, let's go ahead and find out what are the x and y components for this. This is going to be v naught sine of theta, r 22, sine of the angle, which is 60 degrees, and then this is going to be 22 cosine of 60 degrees. So this is equal to 11 meters per second, and then 22 sine of 60 is equal to 19 meters per second. All right, keeping 2 sig figs because I have 2 sig figs here, so that limits the number of sig figs that I have. Okay, so now I can figure out what is t at the top. To figure out that, I say that vy is equal to v naught y plus ayt. That is at 0, that's at the top of the trajectory, is equal to 19 meters per second minus 10 meters per second squared times t. So this is t at the top is equal to 1.9 seconds, solving that for 1.9 seconds. Then to find the height of the ball, so this is part A, to find the height, I say that y is equal to v naught y times t top plus 1/2 ayt squared. That's t top squared. That's going to be 19 times 1.9 minus 5, that's 1/2 of negative 10, times 1.9 squared. That's equal to 18 meters. So that's part A. Then part B, what is the maximum horizontal range? Well, first we need to know what is the time out here. This is going to be twice the 1.9 seconds. So 1.9 times 2 is 3.8 seconds. So what I did there is to find t total. That's twice the time at the top of this trajectory because it takes twice the amount of time to go up as it does to come down, and that's equal to 3.8 seconds. By the way, that is, I think, going to be the answer to number C. Yeah, we'll get to that in just a second. Then to find x, that's going to be Vx times t. Vx is equal to V naught x, which is 11 meters per second, times 3.8 seconds, which is 42 meters. So that's part B. Part C wanted to know the total time for it to come back to ground level. We've already found that. That's 3.8 seconds. And then part D asked what is the velocity at a time of 3 seconds. Now, I already know what Vx is at t equal 3 seconds. At t equal 3 seconds, Vx is equal to 11 meters per second because you know the x component doesn't change. Now I also need to find Vy. That's going to be V naught y plus ayt. And here I'm using the t of 3 seconds. So V naught y was 19 minus 10 times 3. It's 19 minus 30, which is negative 11 meters per second. Hold on just a second. Okay, sorry for the interruption. So now I have the x and the y components. So as my projectile follows this path, my t equal 3 seconds is somewhere right about here. I know that it's passed up the 1.9 second mark, so I can draw my vectors like this. Turns out they have the same magnitude, and I want to know what is this equal to. So in order to find that, I say V at that point is equal to the square root of 11 squared plus a negative 11 squared, and that is equal to 15.6 or 16 meters per second. Okay, so that's the first one. Now let's look at this one. I have 10 kilogram block. There's a rope pulling up on it with 120 newtons. Let's go ahead and just label all my forces here. I have my force weight. I have my force normal. And I'm going to have a frictional force. I'm going to go ahead and put it here. Now there's a frictional force for part of it and then not. So I'm just going to go ahead and label it. And then we'll address that. And then I'm going to draw my coordinate system here and here. And then my angle for this force right here is going to be 90 minus 30 or 60 degrees. Now, let's redraw this with our resolved vectors. I'll do it down here. So I have Fs, Fn, F, which is equal to 120, and then I have Fw sine of 60, and Fw cosine of 60. All right, so I've drawn my forces, and now I resolve my forces onto the x and y axes. And now for the final step, I'm going to do the sum of the forces in the y direction. That's going to equal to 0. That's Fn minus Fw sine of 60 equals to 0. And I can do the same for the sum of the forces in the x direction. Equals max. Let's see, what is my acceleration? Oh, so it is accelerating, so ax is not 0. So this is going to be f minus Fw cosine 60 minus f. Looks like I made a mistake here because this is a kinetic situation, so this will be Fk equals max. So those are my two equations from Newton's second law. Of course, also recognize that I know that Fk is equal to mu k times the normal force. First question is, what is the normal force? So to do that, I can solve this equation. I find that Fn equals Fw sine of 60. That's going to be Fw, which is 100 newtons. I have a mass equal to 10 kilograms times 10 meters per second squared. That's equal to 100 newtons. So I have 100 newtons sine of 60, and that's equal to 87 newtons. Okay, so that's my part A. For part B, I want to assume no friction. And what is the acceleration of the block? So I'm going to be dealing with this equation, but I'm going to take Fk equal to 0. So I'm going to have F minus Fw cosine of 60 equals max. Notice I've just left off the frictional force because now it's 0. That's 120 newtons minus 100 cosine of 60, which is a half, equals to 10 kilograms times ax. So now I can solve this. So I get 120 minus 50 divided by 10 equals ax, and that's equal to 7 meters per second squared. This is going up the inclined plane. I know that's going up because my positive x is in this direction, and so that's going up the inclined plane. That's part B. Part C, what is the coefficient, or excuse me, assume the coefficient is 0.1, what is the frictional force? So for part C, it's just Fk is equal to mu k times the normal force. If I assume that that's 0.1 times my normal force, which I've already found is 87 newtons, that's 8.7 newtons. So that's part C. And then finally for part D, I want to know what is the acceleration. So if I do have this frictional force, I'm going with this. Some of the forces in the x, so that's F, which is 120 newtons, minus the Fk, which is 8.7 newtons, minus that 50 newtons, which was my Fw cosine 60. That's equal to 10 kilograms times ax. And I can solve that for ax, and I find that it's equal to 6.1 meters per second squared, and that's up the inclined plane because it's positive. All right, that's part D. Now, there's the answers there. Let's do the multiple choice. You fire a projectile from ground level at an angle of 60 degrees, speed of 30 meters per second. What is the speed at the top of its trajectory? Okay, so you need to recognize here that at the top of the trajectory, it only has an x component, and Vx is equal to V naught cosine of theta. That's going to be 30 cosine of 60. That's equal to 15. What is the speed of the projectile at the bottom of its trajectory? You have a horizontal launch from 80 meters, has an initial speed of 30 meters per second. So I have this object that goes like this. This distance is 80 meters, and I want to know what is its speed right here. Now it'll have an x component, and I know that that's equal to the initial speed, or 30 meters per second, because I have 30 meters per second here. But it's also going to have a y component, Vy, and I need to figure out what that is. I know that Vy is equal to V naught y plus Ayt. I know that V naught y in this case is 0 because the initial velocity is completely in the horizontal direction. I need to figure out what t is. In order to find t, I say, well, this thing drops 80 meters in a certain amount of time. So I can do it in this way. V naught y times t plus 1/2 Ayt squared. That's going to be 0 minus 5 times t squared is equal to negative 80. It's negative because it starts at 0 and ends at 80 meters below that. If I solve that for t, I get t equals 4 seconds. So if t is equal to 4 seconds, I can figure out the velocity at the bottom by saying v is equal to negative 10 times 4 seconds. That's negative 40 meters. Then at the bottom of my trajectory, I have 40 meters per second in this direction. Then the total velocity, which is in this direction, is going to be the square root of 30 squared plus 40 squared. And that's equal to 50 meters per second. Notice that's a 3, 4, 5 triangle. So 50 meters per second, or c. How long is the projectile in the air? Well, we answered that en route, so it's 4 seconds. Projectile is launched horizontally from a cliff. Which of these graphs represent the x position? So same scenario. I know that the velocity in the x direction remains constant. That means that the slope of the position versus time graph must also be constant. Soccer ball is kicked with an initial speed. Which of the following statements is true? The velocity at the ball at the top is 0. That's not true because it will have a velocity in the x direction. The horizontal component of the velocity is greatest at the beginning. Nope, it's always the same. The acceleration is positive during the second half. Nope, the acceleration in the y direction is always minus 10. The acceleration in the x direction is always 0. The ball's speed increases as it travels upward. In fact, the ball's speed decreases. So that's not correct either. So E is the right answer. Projectile is launched from ground at an angle of 30 degrees. At what point in the trajectory does the projectile have the least speed? That would be at the highest point. At the highest point, Vy is equal to 0, and Vx is always equal to V naught x. Shooting a projectile at a speed of 50 meters per second. What can you do to increase the vertical range? So imagine this is 45 degrees. And I'm launching from this angle at 55 degrees. In order to make the ball go higher, I can do one of two things. I can increase the initial angle. Right, that will make the ball go higher, and I can increase the initial speed. So 1 and 3 are the right answers. Hunter shooting at a target, which is falling vertically. When he shoots, where should he aim? Well, he should aim directly at the target. And then as as the target falls, his bullet will also fall so that they meet at the same point, and then he'll hit that target. So he aims directly at the target, because even though his bullet is traveling at a really fast speed, it still falls at an acceleration of minus 10 meters per second squared. In the same way, the target falls at minus 10 meters per second squared. Okay, so an object is moving across a frictionless surface with constant velocity. Which of these describes its motion? Well, if it's frictionless, that means the sum of the forces equals to 0. That means its acceleration is 0. If there are no frictional forces, it will not slow down. If the object had more mass, it would slow down more quickly. No, in fact, if the object had more mass, it would slow down less quickly. Yeah, so I know even if there was a force acting on it, if the mass is big, that means the acceleration is slow, or the deceleration in this case. So it would not slow down more quickly. It would be the opposite. It would slow down less quickly. The object has no forces acting upon it. That's not true. It has a force weight, and it also has a force normal. Okay, so looks like E is the right answer. Person in free fall, how does the person perceive their weight? They feel lighter. In fact, they'll feel weightless, we say. You know, there is a force weight acting on them, but they feel lighter. Two objects A and B experience the same net force. Object A accelerates at half the rate of object B. So here's object A, here's object B. They experience the same force, but the acceleration of A is half that of B. So let's say this acceleration is 2 and this is 1. Then um, since I know that F equals ma, object A has a smaller acceleration, so object A must have a bigger mass, and it'll have a mass that is twice that of object B. All right. Which of these statements is true? Normal force. Normal force is not always equal to the weight. There are a variety of situations. For example, in an inclined plane where the normal force is less than the weight, normal force always acts in a direction perpendicular to the surface. That's what normal means. An object must make contact with a surface. Yes, you have. It's only in contact forces, and the normal force is measured in newtons. Okay, this is straight from your concept test. Force acts on a mass m1, giving acceleration a1. The same force acts on a different mass, m2, giving an acceleration that's twice what it had before. If m1 and m2 are glued together and the same force acts on this combination, what is the resulting acceleration? So imagine I have a block m1. The block m2, which is going to get twice the acceleration, will have a mass that's equal to 1/2 of m1. So when I put these two blocks together, I'm going to get a mass that's equal to 3/2 m1. Then if I apply that same force to it, since F equals m times A, if I have 3/2 of my original mass, I'm going to have 2/3 of my original acceleration. Okay? Again, that was from a concept test, so we can look back at that concept test too to see a deeper explanation. Newton's second law is known as the law of acceleration. You apply a horizontal force to 50 kilogram mass, 100 newtons, 50 kilograms, and it accelerates at a rate of 1 meter per second squared. Now, if it was actually no friction, I would have a rate of 2 meters per second squared. So it's accelerating at a rate that's slower than you would expect. Let's do the sum of the forces. I have 100 minus Fk is equal to m times A. Um, so Fk is equal to 100 minus ma, 50 times 1. That's equal to 50 newtons. So I have a frictional force of 50 newtons. So 50 newtons is equal to mu times my normal force, which is 500 newtons, because I have a normal force here that will be equal to the weight, and that weight is equal to 500 newtons. So mu is 50 over 500, which is 0.1. Okay, 50 kilogram block is suspended by a rope. It's ascending at 2 meters per second squared. I can draw my forces here. I have a force tension and a force weight. Ft minus Fw is equal to m times a. So I'm looking for Ft. That's going to be equal to Fw plus ma. That is 500 newtons. I got that because it's 50 kilogram block plus 50 times 2. That's equal to 600 newtons. So D is the right answer. Push on a 2 kilogram block against vertical surface. The block does not slide. What is the minimum coefficient of friction? So I have several forces. I have the weight acting here. I have this force that I'm pushing in. I also have a static kinetic frictional force, and then I have a normal force, Fn. Let's draw this on our coordinate system. And then there's my normal force right there. From this, I can say that Fs is equal to the weight, and I can say that Fn is equal to the force. So Fs, in order to hold this block up, has to equal to 20 newtons, and Fn is equal to 50 newtons. Then I know that Fs equals mu times the normal force, so I'm looking for mu, just 20 over 50, or that's 0.4. Okay, so consider this block. What is the coefficient of kinetic friction? It accelerates down the block at 3.25 meters per second squared. So I draw my force weight. I draw my Fk. I draw my normal force. And I think that's it. Yeah, that's it. So now I'm going to draw my coordinate system and resolve those vectors. And I know this thing is accelerating. I can do the sum of the forces in the y direction. That will equal to 0. So Fn minus Fw sine of 60 equals 0. I'm just going to go ahead and calculate that Fn equals Fw, which is 200 newtons times sine of 60. That's equal to 173. That's my Fn, and then I can figure out what my Fk is by doing the sum of the forces in the x direction. That's going to be Fk minus Fw cosine of 60 equals to max, and it is accelerating. So that's Fk minus 100 equals 20. That's where you got to be careful. Minus 3.25, because notice my acceleration is in this direction, in the negative x direction. If I solve that for Fk, I find that Fk is equal to 35 newtons. So then I have 35 newtons equals mu times my normal force, which is 173, and I solve that for mu, and I get 0.2. Okay, consider this figure. The block is stationary. Which of the following equations is correct? Let's just draw my equations. My normal force. I have a static frictional force. I have a weight. I can write my resolve vectors. Fn, Fs, Fw cosine of 60, Fw sine of 60. So, Fw cosine 60 minus Fs is equal to 0. That's this force minus this force. That's correct. Fn equals Fw sine of 60. That's correct. Fs equals mu s Fw sine 60. This is the same as saying Fs equals mu s times the normal force. So, yeah, that's correct too. You can see, because this is the normal force. and then the sum of the forces in the x is equal to 0. That is true because it's not accelerating. So that's the right answer. And here, these are all wonderful students, but E is the right answer. Okay?